I'm really happy to have Ashley here today as our guest speaker. And she's going to tell you about a great volunteer opportunity and carbon emissions research that Skyland is helping with this year. So I'll pass it over to Ashley. Oh, one more thing before we get started. If you have any questions while Ashley is presenting, please put it in the chat. And at the end of the talk, we'll do a Q&A once she's done. So I'll pass it over to Ashley to introduce herself.
Thank you, Megan. Hello, everybody. Thank you guys all so much for being here. To give a little background about myself, my name is Ashley Cadena. I'm a first-year PhD student. I studied chemistry at UC San Diego for my undergrad, and now I'm at Northern Arizona University. I'm here presenting the Southwest Urban Corridor Integrated Field Laboratories. And yeah, I hope you guys enjoy my presentation. So once again, the title of my presentation is called Annual Plant Radiocarbon and Traffic Modeling App Launch, Empowering Community Science for Urban Fossil Fuel Emission Modeling. And before I start off this presentation, I want to let you guys know what the goal of this presentation is for me. So first, I want to educate you all on the background of this project, introduce what the Hestia model is, highlight the use of annual plants in this project, show you the process of how we are processing our samples and provide updates on our data. And lastly, and most importantly, I would like to encourage you all to participate in this community citizen science project. So let's start off with some background to this project.
Ashley, you're not sharing your screen. If you want to go ahead and do that, please.
Oh, is it not sharing? I'm so sorry.
You're good.
It did say that I was sharing screen.
Sorry, it might be me, actually. I'm on the wrong Zoom.
Yeah, it looks fine on my end.
Sorry.
Okay, so you guys can see my screen.
Yes.
Okay, perfect.
Yeah, we see background to the project.
Got it. So let's start off with some background to the project. So first of all, once again, I'd like to thank you all for your participation in this project or even just listening about this project. We truly would not be able to do this work without the help of our citizen scientists. You guys are all educating us and collecting valuable data, and I would like to acknowledge the hard work and dedication you all have inputted into our project. And I want to highlight the importance of community science. So through community science, we hope to foster local empowerment through environmental awareness, help bridge the gap between research scientists and public participation to take action on climate change issues. I feel like most of the time I always feel like there's a disconnect between scientists and their community members. So through this project, once again, I hope that we're able to bridge that gap and foster room for scientists and community members to grow together. So I'm sure you're all aware of the persistent and heavy climate change impacts that we are experiencing right now. We are experiencing the effects of climate change in the form of extreme weather events. Most recently, this has been really prevalent in the Los Angeles area with the wildfires that occurred back in January, which were fueled by hotter, drier, and windier conditions. And so it's important to note that climate change is driven by greenhouse gases and is seen in the graphic to the right-hand side, this pie chart. You're able to see that carbon dioxide from fossil fuels and industrial processes is the biggest contributing greenhouse gas. So you might be wondering, what are the sources of fossil fuel emissions? So in urban areas, fossil fuel emissions stem from vehicles, industrial processes, energy production. Now, what about Phoenix and Tucson? Well, due to the city's rapid growth rate, over 50% of emissions can be attributed to transportation, which lead to an increase of air pollution levels as well, as I'm sure you guys may notice in your guys' area. So now in comes our beloved Hestia model into the picture. So you might be wondering, why do we need to model fossil fuel emissions? Well, in order for us to create policy change that can help us reduce fossil fuel emissions, we need to know where and when the emissions are coming from. Carbon dioxide is not a regulated pollutant, so policymakers do not have this information. So what is Hestia? It's a cutting-edge modeling system that offers accurate estimates of fossil fuel carbon dioxide emissions, air quality, and human-generated heat, all at a high precision in space and time. It's focused on individual cities. The Hestia app helps us understand and enhance our urban ecosystems. Fun fact, this model is currently being used across 11 different cities in the whole world, and we would like to implement it here in the state of Arizona. So what will an improved Hestia model do for us as citizen scientists? Well, first and foremost, it will provide actionable data that is needed for these cities, as I had previously discussed before. Our cities will be able to implement the changes to reduce congestion, which will then help optimize bus routes and improve public transportation. Second of all, it will provide accurate data for cities to implement changes aimed at reducing emissions through better traffic management and city planning. And last of all, it will provide detailed emission data on all building, energy, and on-road sectors that cities can use to craft policies that will target carbon dioxide hotspots and reduce energy use, which will help mitigate climate change. So to put it all together, an improved Hestia model will 1, reduce congestion, 2, improve public transportation, 3, reduce emissions, and 4, improve climate action plans. So the Hestia model is built using data from 9 segments. The model shows here that the road sector is the highest source of carbon dioxide. Well, the 9 segments that are included are electricity production, airport, non-road, on-road, railroad, commercial, industrial, residential, and cement emissions. And here in this big blue area, 43% of that is made up from on-road emissions. But as of now, we have 2 data gaps that we hope to fill in with the help of you all, the volunteers. So I will now talk about each gap. Now to preface this, our model has 2 data gaps. And in order for us to help fill in these data gaps, once again, we need the help from our beloved volunteers to make our model and improve the Hestia model. So what's the first gap? We are lacking information on traffic patterns and vehicle classifications. So the Hestia model is missing vehicle type, the time of day or week these vehicles are seen on our railroads, as well as a variety of roadways that these vehicles are traveling on. That means we don't know what time of day we see a big truck, a trailer truck, or a motorcycle. We have no data of that. The state of Arizona does not collect that data. So for example, in Flagstaff, we only have 5 locations of data and only 1 average vehicle type. So you can see that this is not encompassing the whole city of Flagstaff, but yet it's using these 5 points to account for fossil fuel emissions. But by using the traffic app, we can move to getting data from many, many, many locations across the city, as shown in all these points. And from each of those points, we can get vehicle class. So for each count, by counting each individual car by vehicle type, we begin to build detailed information about different road segments that will improve our ability to model fossil fuel carbon dioxide emissions. So that detailed data will help strengthen the Hestia model, and we'll be able to get much more refined, actionable data for policy users to use. So you might be wondering, yeah, you talked about all this. How do we do it? Here comes a Hestia traffic count app, which is a phone-based app to collect vehicle counts. So you observe vehicle counts at a sample of roadways will make a big difference in an on-road emission accuracy. So by simply taking traffic counts when you're out and about, we can begin to build our database. We hope to collect all these data into our data, and then that will help us better the Hestia model. Now I'll be talking about the second data gap that the Hestia model has. So our second gap involves validating the Hestia model. How do we do that? So traditionally, air flash samples taken from towers, as seen in this image on the right-hand side of the slide point, or airplanes are used, but it's expensive to get multiple samples across an area of interest, and they do not capture high temporal variability that is associated with fossil fuel emissions. So how do we fill this gap? What if we could use annual plants instead of flask measurements? We could collect many more samples across our areas of interest because annual plants are deployed everywhere naturally. Annual plants can also integrate the fossil fuel carbon dioxide emissions across the plant's lifespan, which increase the temporal resolutions of our samples. So this ability to use many samples across the gradient will help with verification and evaluation of the Hestia model. And here on the right-hand side, you're able to see the London rocket, which is an annual plant in Tucson. And on the other image shows a stinknet, which is an annual plant found in Phoenix. So to kind of wrap it all together, radiocarbon that is collected from annual plants and the Hestia Traffic Modeling app offers innovative tools for tracking and analyzing urban emissions. And this application will help empower communities to visualize their contributions to fossil fuel emissions and aids in driving policy changes based on accurate data. So now a quick look back at our overview of how our volunteers can help us fill these data gaps within the Hestia model. The first one would be utilizing the Hestia traffic app, and the second gap can be filled with collecting annual plants around your area. Okay, so you heard radiocarbon, but have no clue what it is or how plants even have it or how we could collect fossil fuel carbon dioxide levels from it. So I'll give you guys a brief overview about that. So what is radiocarbon? Radiocarbon, also denoted as 14C, is a radioactive isotope that's formed in the upper atmosphere when cosmic rays hit nitrogen. It is taken up by living organisms through carbon dioxide and through plants via photosynthesis. Now to zoom in onto this picture down here, you see how carbon combines with oxygen to make carbon dioxide, in which some of that carbon will contain 14C, or radiocarbon. So thus, fossil carbon dioxide containing radiocarbon is found in our atmosphere. And as you guys all may probably know, annual plants actively are observing carbon dioxide throughout their life cycle, which serves as an indicator of atmospheric changes, and their widespread presence allows scientists to capture and analyze the fossil fuel carbon dioxide signal in urban settings. To explain this image a little more, here's a happy little annual plant. It's using light energy from the sun, carbon dioxide from its atmosphere, water, and it's releasing oxygen. So these plants are able to capture and are constantly capturing carbon dioxide emissions. So everything changed for radiocarbon in the 1950s. So radiocarbon occurs naturally, but it is rare, and it mainly exists in the atmosphere because of hydrogen bomb testing that occurred in the 1950s and 1960s. Hence, there is a big spike in the global atmospheric radiocarbon, which is seen on this following graph on the right-hand side. We are able to see that there's a big bomb pulse in the 1950s and 60s, and the concentration of radiocarbon increased. But fossil fuels being formed from ancient organic matter lack radiocarbon due to its decay over millions of years. Consequently, the combustion of fossil fuels leads to a dilution of atmospheric radiocarbon concentrations. So as the new carbon that's introduced, it lacks the radiocarbon isotopes. So this phenomenon results in a measurable decrease of radiocarbon in the atmosphere. Once again, in this graph, you are able to see how radiocarbon values went so high during the bombing period, after the bombing period, but as time decreases, it's being mixed with fossil fuel carbon dioxide, so the presence of radiocarbon slowly starts to decrease. So, in summary, once again, fossil fuels do not have any radiocarbon because they're so old. So fossil fuels burning have diluted the atmospheric radiocarbon. Plants uptake all of this carbon dioxide. So plants near fossil fuel carbon dioxide sources will have more diluted radiocarbon. Annual plants integrate fossil fuel carbon dioxide signals across the plant's lifespan. Annual plants are deployed naturally almost everywhere since many weeds are annual plants. And sampling annual plants increases the spatial and temporal resolution of carbon dioxide across cities. So how do we process our samples? First, we obtain plants collected by volunteers, hopefully you all. Here you see a student collecting plants, as well as annual plants that are collected in the Phoenix area, Flagstaff, and Tucson area. Once we receive the envelopes in this plant samples at Northern Arizona University, we use a coffee grinder to completely grind up our plant to make sure that our plant is evenly distributed across. Here you're able to see this is the plant in the beginning when we received it, and after it's been grinded, it's all fitted into this tiny little glass vial, which takes a lot of work and a lot of time. Next, we roll our samples into this little tiny tin foil capsule that is seen right here that we're able to use it on our instrument. So it's crazy because all of the sample from the plant is in this glass vial, but we get it into be this little tiny mass amount of it. So at Northern Arizona University, the Arizona Climate and Ecosystem Isotope Laboratory has a first rapid throughput mini carbon dating system, the McCadis, which is seen here on the left-hand side. This instrument is what reads that little tiny capsule so that we are able to obtain radiocarbon values. So it measures radiocarbon values on carbon dioxide gas rather than a traditional graphite. So the elemental analyzer on the right-hand side combusts our solid plant samples, and carbon dioxide directly is inputted into the mini carbon dating system. So a gas analysis has a higher sample throughput with a somewhat decreased precision. So after we have combusted our plant and observed a radiocarbon value in the mini carbon dating system, what are our results? What does that look like for us? So I do want to, before I share the results, I want to let you guys all know that this is a 5-year project. So I've been working hard on data analysis and understanding how to view our current results and their implications. So with the help of volunteers from Desert Botanical Gardens and Sky Island Alliance across Tucson and Phoenix, our Citizen Science of 2024 results show that 59 observers collected plants, and we received over 1,200 annual plant samples. Now for the Hestia app, since its launch in May 2024, we have 270 users and 1,500 traffic counts across the United States. Now here is the plant collection and radiocarbon values that we have received and observed across Phoenix, Arizona. The key on the right-hand side indicates radiocarbon values because once again, radiocarbon is depleted in fossil fuel emissions. The more negative values indicates the carbon is coming from fossil fuel emissions. So think about it like this. The more red the dot is, that means that most of the carbon from there is from fossil fuel emissions. So here we see a trend of red dots, and this is all along the 10 freeway, which is not much of a surprise because there's a lot of cars and transportation that occurs in that area. Whereas in more rural areas, such as this purple dot on this side, you're able to see that there's a more positive radiocarbon value, which indicates that the carbon for that plant is coming from radiocarbon. So this Hestia model this Hestia model that I have shown you guys on the screen right now is using data from the 9 sectors that I had previously mentioned in the past. And this all data has been collected in the past as well. So the red signifies high fossil fuel carbon dioxide emissions. And here you can see that the Phoenix Harbor Airport is a high source of fossil fuel emissions. The pink dots on this map represent areas in where we have collected plant samples to validate our model. So I want to once again emphasize that this is revolutionary science, science that transforms understandings. Because many research papers use radioisotopes to understand carbon emissions, but none have a precise model, aka Hestia, to compare the results to. So together, we're all pioneering this upcoming world of new science. Thus, we're actively working to understand what the plant is actually seeing in terms of fossil fuel emissions. So our scientists are trying to relate how we could use the plant to verify the model. We need to take into account different wind directions and how different wind patterns are impacting what these plants are witnessing. So our question is, how big of an area do these plants represent in terms of fossil fuel emissions? In other words, we're just trying to figure out how big of an area the plant sees so that we can relate it back to the Hestia model. So here's our little plant in the middle. Is it seeing this size of an area? Is it seeing this bigger red dot line graph of an area? What is the plant actually seeing? And that's what we're currently trying to figure out. Now, to tie it all up together, let's zoom in onto this little infographic. So here is the urban environment, whether that be Phoenix, Tucson, Flagstaff, and our citizen science find themselves here. They can go in one or even better in both directions. So the first direction, you guys will collect annual plants and use your phone to locate these annual plants, ship out the samples to Northern Arizona University, where it get processed in the ACE lab at NAU, which will help generate radiocarbon values to validate the Hestia model. Direction number 2 uses the Hestia traffic count app to count traffic and classify vehicle types at the specified locations, which will then help fill the data gaps in the Hestia model. Above all, the main purpose of this Hestia model will be to help reduce fossil fuel emissions, improve public transportation, reduce congestion, and improve climate change action, with the overall goal to help mitigate the effects of climate change. So where do we go from here? The next steps and our call to action include 1, help us locate and collect annual plant samples in Phoenix and Tucson. This is simply merely done by locating an annual plant, using an app called iNaturalist to capture the image and location of the plant. And the third step is to collect the annual plant and send it over to NAU. Secondly, download the Hestia app to help us count traffic and fill our data gaps. The Hestia app can be found on the App Store if you're an Apple user, or it can be found on Google Play if you're an Android user. And with that, I would like to end my presentations. I hope you guys are encouraged to help participate, to help us collect data and participate in community citizen science. I'm thankful for all of you guys listening to my presentation, and I'll be taking questions from now. Thank you.
Thank you so much, Ashley. That was wonderful. For everyone listening, I posted in the chat links to our overview blog that talks about how you can get involved with both the traffic app and the plant sampling. But if you have any questions, you can reach out to me, Megan Bethel, to help you get started as well. I didn't see any questions come into the chat, but if anyone wants to unmute themselves and ask a question, please do. Mitty just asked, can cameras at intersections be used to collect traffic data?
So I'm not sure if that's being used, but we are currently working with the Arizona Department of Transportation to collect these data. And the data that they have is not as precise that we would like to. As I previously mentioned, it's more of averages of vehicle types and only certain locations in certain cities. So I don't think the data from intersections is accessible for us.
Yeah, just shows the power of citizen science and just getting out there and collecting that data. Sometimes it's the fastest and easiest way. Yes, there's a question with the severe drought we're seeing, are we expecting any annual plants? That's kind of the waiting game. However, there are annual invasives coming up in irrigated parts of town, like London Rocket here in Tucson. If you go anywhere where there's irrigation, there are plants, so we recommend if you see them and you want to get involved, reach out. We have envelopes, so you can collect them. And that certainly counts. Last year we had so much London Rocket, it was very easy, but this year will be a little more interesting.
And to also, if there is no plants to collect, still using the Hestia app, which I have QR codes on the screen right now. You guys can also help us very much if you guys are able to download that app right now and kind of focus on that for the meanwhile we wait for these annual plants to hopefully grow.
Yeah, it's a double-edged sword because you want the rain, but also they're invasives, but it's hopefully we get some rain this weekend. Mindy just asked again, is London Rocket okay, or is any other invasive, any other plants? We do have a list on our website, but basically any annual invasive plant. That way it's taking the carbon from that year and you're getting rid of an invasive plant from the environment too. So
Yeah.
if you want to speak on that, Ashley.
Alyssa asked if there is any similar projects in Southern California. I'm not currently aware of. The Hestia model app is currently being modeled at Los Angeles Hestia model, but they didn't use annual plants, or sorry, they didn't use community citizen science for collecting of their annual plants, but that study was in 2019. So I'm not sure if there are any other or similar projects found in Southern California, unfortunately. But you can find out if you go to your local botanical gardens and just ask around.
There's a question about how long the survey is going to run. For the traffic app, that started now until it's an ongoing project, so it can be done at any time of the year. For the plant sampling, we are looking at the annuals from the spring, before it gets too hot and everything gets crispy. So April probably be around the tail end of it, but we'll play it by ear. Oh, thank you. Someone's already, I don't know what your initials are, PFM, but they've already done a traffic sample and they're putting out a difficult question of determining SUVs. That is kind of a trick, but once you get to practice, you'll pick them out pretty easily. Thank you for that feedback. And then what question from Azetta? Can we sign up to collect plants as we did last year without having to do the traffic counts? Yes, you can do either project or both projects. That's totally up to you and your comfort level and what you want to get involved with. If you want to go ahead and reach out to me right now, we can get that worked out. We also have some plans for in-person trainings. We just have to pick out the date still. And yes, I'm the contact information, Megan. I'll put my email in the chat if you want to contact me. And there's also information in that blog post about how to pick up envelopes. thank you everyone for your participation.
You know, I'm so happy looking at all these comments. Izetta asked, is there any planning in Tucson to designate certain areas to study, such as South Tucson and the airport areas? So we're currently working with mapping out the locations that we would prefer to have plants plants collected in, depending on our Hestia model. I don't know. I know, Megan, you worked with the pinpoints on where the Tucson area plants wanted to be collected. Do you know if you saw any of South Tucson or near the airport area?
Yes, we do have a plan to roll out targeted locations, and we'll be recruiting volunteers to go out to these specific spots to sample these locations to see if there's a plant or not, and then collect it. And a lot of these are along the more densely populated areas near the freeways. However, we don't quite have those points ready yet, so we wanted to roll out just the general random sampling, which also is great. And if you happen to see plants down by the airport as you're going by or wanted to go check it out ahead of time, please do. Thank you.
Yeah, it never hurts to have so much data. The more data we get, the more that we'll be happier.
Yeah, and the plants are up now, so it's like, well, let's get a head start. If it's irrigated, it seems like.
Yeah.
Any other questions? Those were great ones.
I also wanted to share is if you guys all had the chance to download the app, or if you guys are having any technical difficulties, feel free to leave those in the chat, because I know it can be a little bit hard to navigate an application for the first time.
One last question from Izetta again. I noticed that last year too, that once the plants dry out, they are harder to identify and collect too. The iNaturalist project is live as of today. And the traffic app is live as well, so you can get started as soon as you want. But yes, it is easier once they're green and fresh.
Great.
Great, cool.
Okay. Any last questions?
Okay, everyone, thank you so much for being here. This is being recorded, so we'll have it on our website in a day or two, and it'll be emailed to all the attendees. Thank you so much for helping collect this data, and I hope you have a great night. And thank you, Ashley.
Thank you all so much. I appreciate you all so much.
Have a good night. Bye-bye.